Next, let us talk a little bit about the higher order derivative. Okay, suppose y equals to f of x is a function whose graph is given like this. Okay, so how do we denote the first derivative? The first derivative is denoted by f prime of x, right? Y prime or f prime of x, or sometimes we denote by dy over dx, right? These are the notation we use. This is or. So this is another notation. Okay, so how would the graph look like? Okay, so for the graph of f prime of x, look at this. The function is increasing left to 1. So left to 1, the graph must be above x-axis. You can think, okay, let's look at this. Left to 1, the graph of f prime must be above x-axis, because that must be positive. Why? Because left to 1, the function f is increasing. So, and also between 1 and 3, the graph is decreasing, meaning that you can have like this, right? Between 1 and 3, the graph is decreasing. Okay, and after 3, the graph is increasing, meaning that that must be above x-axis. This must be f prime, right? This is the graph of f prime of x. Okay, so the second derivative is basically the derivative of y prime. The second, so whatever you get in the derivative of y, that is y prime, you find out the derivative of that thing. Okay, so that we denote by y double prime, or you denote by f double prime of x, or you denote by d2y over dx square, or dx2. This is the notation for the second derivative. Okay, so the first derivative gives you slope or the velocity, but the second derivative gives you the rate of change in the first derivative. Okay, that is also called the acceleration. So the rate of change of the velocity or the rate of change of the slope of the function, that is also called the acceleration. Second derivative gives you the acceleration. So if you are asked to find out the acceleration of an equation that represents the path or the position of the moving object, then you will have to find out the second derivative. Okay, so how would the graph of the second derivative look like in this case? So look at this. The graph is decreasing. Okay, the graph is decreasing left to 2. So it looks like this, right? So the second derivative must be below the x-axis, so it must be negative, right? The second derivative must be negative, and the graph is increasing up to 4, so the second derivative must be positive, right? And after 4, it is decreasing. So you can think of that type of graph for the second derivative, right, of fx. The second derivative means f double prime or y double prime or d square d2y over dx2. You can think that way. Okay, guys. So how about the third derivative? What is the notation for the third derivative? You can denote by y triple prime or f triple prime of x, or d3y over dx 3. Okay, we don't use the graph of the third derivative and the higher order derivative than second derivative. Okay, so that much. So y iv or 4 primes, or f ivx, or d4y over dx4. So that is the notation for the fourth derivative. Let us see some examples. Okay, let us see the example number 1 there. So y is given as 7 times x to the 1/2. Find y double prime. So let us find out first. We need to find out y prime, that is 7 times 1/2 times x to the 1/2 minus 1, because 7 is a number, so you can pull that out, and then you use the derivative of x to the 1/2. What is the formula? X to the n prime is n x n minus 1, right? Prime stands for the derivative. So if you simplify this, you will get 7 over 2, because 7 times 1/2 is 7 over 2, then times x to the negative 1/2. I'm not moving this to the down before I find out the second derivative. So let's find out the second derivative. So y double prime is the derivative of that thing. Okay, that will be 7/2 is a number, so you can pull that out, and then find the derivative of that x to the negative 1/2. That will be negative 1/2 times x to the negative 1/2 minus 1, right? Nx n minus 1. That will give you negative 7 over 4. Why? Because 7/2 times negative 1/2, will be 7 times negative 1 is negative 7, 2 times 2 is 4, times x to the negative 3 half. Now I don't want to keep the negative exponent, so what I want to do is negative 7 over 4x to the positive 3 half. You can write that way, or if you want to, you can write negative 7 over 4 and then square root of x cubed, because that 3 over 2 that goes to the square root, okay, because this is like x to the third times 1 half, that way. Okay, this is the final answer, or this is the final answer. So how about this one? For this problem, you have a quotient rule, right? It is like u over v, right? So what is the formula for u over the derivative of u over v? It will be f prime, the first derivative will be u prime v times v minus u times v prime over v square, right? So how that look like? It will be u prime is 1 times v is t minus 1 minus u is t times v prime. The derivative of t minus 1 is just 1, right? Divide by t minus 1 square. Let us simplify, okay, because you need to find out another derivative for this one. So it is basically t minus 1 times 1 is t minus 1 minus t divided by t minus 1 square. So if you cancel out those t, positive t and negative t, then what is left there is basically negative 1 over t minus 1 square. T minus 1 square. Now we need to find out the second derivative. Okay, how do I find out the another derivative? So f double prime, this is also a quotient rule, right? This is also a quotient rule. It is like u over v, right? But what is v? V is t minus 1 square. So what is t minus 1 square? T minus 1 square is basically t minus 1 times t minus 1, right? If you FOIL this, FOIL, you will get t square minus twice t plus 1. This is what you get, okay? So how do I find out the derivative? Again, you use that formula, same formula, right? U is negative 1. So the derivative of u is 0 times v is t minus 1 square minus u is negative 1 times v is, what is v? V is t square minus twice t plus 1. You need to find out the derivative of v. So the derivative of t square is twice t, and minus derivative of twice t is 2 times 1 and then plus 0. That is the derivative of v prime, right? That is the v prime. So now we need to square the denominator, or square that one, v square. So that will be t minus 1 to the fourth, right? If you simplify that, what do you get? The first term is basically 0, right? And then the second term is basically, what you get there is a positive, negative times negative 1 is positive. So twice t minus 2. So twice t minus 2 divided by t minus 1 to the 4. But you can factor the 2 out, right? What is left is t minus 1 over t minus 1 to the 4. You see that? But you can cancel one of those, right? Because there is t minus 1. There are 4 of the t minus 1 multiplied together. So if you cancel one of those, then what is left is there is only 1 left there, right? That only 3 left. So that is 2 over t minus 1 to the third. That is the second derivative of this function. So basically, to find out the higher order derivative, you should start from the first derivative and then find out the second derivative and then find out the other derivative that you need. So you need to do turn by turn, okay? Let's do this one. You need to find out the third derivative. Let's find out the first derivative first. So g prime of x is equals, it is like u times the v, right? What is, do you remember the formula for the product rule? So it is like u prime times v plus u times v prime, right? So that's what we want to do here. So what is u prime is 1 times cosine of x, and then plus, there is a plus for the product rule, there is minus for the quotient rule, don't forget that. And then u is x times u prime times v. U prime is 1, v is sine x, right? So I don't find out the derivative of sine x for the first time. So it is sine x stays sine x plus x, the u stays the same, and then v prime is cosine of x. So if you simplify that, you will get sine x plus x cosine of x. Now I want to find out the second derivative, okay? So to find out the second derivative, you use that function. So it is like the derivative of sine x is cosine x, but it is like u times v. So again, there is a product rule, right? So what is g double prime of x? It is the derivative of g prime. So derivative of sine x is cosine of x plus, here you use the product rule, right? So u prime is 1 times cosine of x plus u means x times v prime is negative sine x. So if you write in the simplified form, you will get cosine of x plus cosine of x minus x sine x, right? That's what you get. So how much is that then? So you get cosine x plus cosine x is 2 cosine x, right? So let me write one more simplified form. 2 cosine of x minus x sine x, okay? Now I want to find out the one more derivative there, right? So g triple prime of x, that's what you are asked to find out there, right? So that is basically the derivative of 2 cosine x is 2 times negative sine x, right? Because the derivative of cosine x is minus sine x. So it is like u times v again minus. So the derivative of u times the v, right? And then plus u times the derivative of v. Now you need to distribute that negative sign to all of those. So what do you get? The final answer will look like this: negative 2 sine x and then minus sine x, right? And then minus x cosine of x, because you need to distribute that to both of these, right? So if you simplify, then you will get negative 2 sine x minus sine x is negative 3 sine x and then minus x cosine of x. So this is the final answer for the third derivative of this gx function, okay? So the last one is very conceptual question, okay guys? So how do I do the last one? Let us do the last problem, very last problem there. So look at this. So here the function fx is given like this. The function is increasing left to 1. So let us write down what is given there. So f is increasing left of 1 and right of 3 and right of 3. So what do I need there? So at these points, left of 1 and right of 3, what do I need is f prime of x must be positive, meaning it must be above x-axis, okay? So f is decreasing, okay, between 1 and 3, right? We are looking at the function f. So at in this piece, on the left of 1 and right of 3, you need the first derivative. The graph of the derivative is positive, meaning the first derivative positive means the graph must be above x-axis. The graph of f prime must be above x-axis, and here the graph of f prime must be below x-axis. That must be negative. Okay, let us see which of the graph have that property. Okay, so here, what is f prime? So this is f prime. Okay, let me write down that is f prime. The blue is the f prime and the black curve is the f double prime in all of those. Okay, so on the first one, let us look at this. On the first one, f prime is negative left of 1, but we need f prime is positive left of 1 and right of 3. Okay, so this is not the right answer. Okay, how about this one, b? On the b, this is f prime. Okay, this is the f prime. The blue is the f prime. So the graph is negative less than 0. Graph is negative because it is below. And between 1 and 2, it is positive. But that's not right here, right? Because what we need is left of 1, it must be positive. And right of 3, it must be positive. But this is not the right answer as well. How about C? We need left of 1 and right of 3. The graph must be above x-axis. The graph of f prime must be above x-axis, okay? So let us look at that. Left of 1, it is above x-axis. Right of 3, it is above x-axis. It looks like it is, okay? So, and then on D, so the left of 1, look at this f prime. Left of 1, it is not positive because left of 0, it is positive. Between 1 and 0, it is negative. So this is not. So this must be the possible graph, okay? So this must be the possible graph, but we need to look at the graph of f double prime as well. Look at this. So for f prime, this is the right graph. For f double prime, look at this. F prime is increasing left of 0. So f prime is increasing left of 0 means the derivative of f prime, f double prime must be positive. Yes, that is right. Between 0 and 2, between 0 and 2, f prime is decreasing. So its derivative must be below the x-axis. This derivative must be negative, right? So let me write down that. So f prime is increasing. F prime is increasing on x less than 0 and x greater than 2. Look at this. Because this is the right graph for f prime, right? So let us look at the property of f prime. F prime is increasing left of 0 and increasing right of 2. Okay? And then, so here, on this case, its derivative, meaning f double prime must be positive. And f prime is decreasing. F prime is decreasing between 0 and 2. 0 and between 0 and 2. So in this case, its derivative, f double prime must be less than 0, right? Does that agree here? For x less than 0 and x greater than 2, the derivative must be positive. The black curve must be positive. Yes, that is right. Oh, between 2 and 4. Between 2 and 4, and after that, let us look at that. So it must be like this. Okay, so after 4 it is decreasing. Okay, so and then you can say that f prime is decreasing between 0 and 2. Between 0 and 2 it is decreasing, so the graph must be below. That is right. The second derivative graph is below. And then after 4 it is decreasing. After 4 the first derivative is decreasing, meaning it must, between 2 and 4 the graph is, the f prime is increasing, so the graph of f double prime is above x-axis. And after 4 it is decreasing, meaning it must be the second derivative graph must be below the x-axis. So this is the correct graph. So this is the right answer. Okay guys, so it is very conceptual, but if you look very, very closely, look at each derivative and its increasing and decreasing pattern, and then the sign of the derivative of that function. Okay, that will give you the complete figure. Okay, for the derivative and the second derivative of a function.